when two electrodes, a positive electrode P and a negative electrode N, are dipped in an electrolyte, then there develops a potential difference between the positive electrode P and the interface between the electrode and the electrolyte, which is represented by the boundary A. This potential difference is, let's say, potential difference between P and A, which is V positive, and V positive will be greater than 0. Similarly, a potential difference also develops between the negative electrode and the interface B between the electrode and the electrolyte. So this potential difference, which we call as B NB, will be equal to minus V minus, which will be also greater than 0. V minus because it's a negative terminal, and this minus sign indicates that the potential difference is in a direction opposite to the direction in which the potential difference at the positive electrode has developed. So the total potential difference between the two electrodes is given by V plus minus of minus V minus. So this is the difference between the potential differences at the two electrodes. So this comes out to be V plus V minus, which should be greater than 0. This potential difference is called EMF, or electromotive force. It's represented by the Greek letter epsilon. Now you might be wondering, why is it called electromotive force or EMF? Partly the reason lies in history. This potential difference was discovered long before the phenomenon as to why that potential difference exists was discovered. So the reason attributed to the potential difference was discovered much later, when electrons and ions were discovered. But the phenomenon was known much earlier, and since this potential difference, caused a force to exist in a circuit connected, it was given the terminology force. So it's actually a misnomer, but today we continue calling it EMF nevertheless. Now when I connect the two electrodes, the positive and negative electrode, through an external resistance capital R, and I close the circuit, then current from positive electrode to the negative electrode N flows through the resistance R in this direction, and internally through the electrolyte the same current, let's say I, flows from point N to P through the electrolyte in this direction. Now suppose the electrolyte has an internal resistance of, let's say, small r. Internal resistance of electrolyte is, let's say, small r ohms. Now when the External resistance is infinite when R is extremely huge, infinite. That means the current flowing I is given by V by R, which is V by infinity, which is equal to 0, which means current is practically 0. The current flowing here is 0. Then the potential difference that exists between points P and N, the potential difference between points P and N is given by the potential difference between P and A plus potential difference between A and B plus the potential difference between B and N. So potential difference between P and A, clearly we discussed it previously, was V plus. Potential difference between B and N, we discussed it as minus V minus. And potential difference between A and B, because the resistance is infinite and there is no current flowing, it is equal to 0. So which reduces this to V plus V minus, which is nothing but epsilon. Suppose R is finite, then the potential difference will denote it by V, which was previously, when R was infinite, it came out to be V plus V minus, which we said this came out to be epsilon. Now, when R is finite, there is certain amount of electricity flowing, in which case there will be an additional factor of the potential difference between points A and B. So this will be the potential difference between A and B. So if I replace this term by epsilon, then this term will now be I, which is the current flowing through the entire circuit, multiplied by the resistance of the electrolyte, which we took it to be R. I also introduce a negative sign here for the simple reason that the direction of current flow through the resistance R, capital R, is in one direction, and conventionally speaking, the current flowing here is in the opposite direction. Hence, I take it with a negative sign. So effectively, I get the potential difference V is equal to epsilon minus I R. Typically, in batteries, the internal resistance is assumed to be negligible. Hence, the total potential difference that a battery provides is equal to epsilon. But again, if you compare dry versus wet dry batteries have quite a significant amount of internal resistance. Hence, sometimes we do need to take the internal resistance into account. Now, if I take this a step further, what is V? This, on the right hand side, this equation gives me the potential difference between points P and N through the electrolyte. And what is the left hand side give me? It gives me the voltage across the resistance R. Now these two should be equal. So V can be replaced as I into R equals epsilon minus I R. If I bring this term to the left hand side, I am left with IR plus IR equals epsilon, which finally gives me I equals epsilon by R plus small r. So effectively, I am getting the current through an electrolytic cell connected through an external resistance to be the electromotive force of the cell divided by the sum of the external resistance and the internal resistance of the electrolytic cell.